Okay, they're uniform.
Mixtures can be separated physically.
Thank you, Brevin. He said mixtures can be separated physically. Hey, Tanner. Mixtures can be separated physically. And then we talked and reviewed solute versus solvent, which you guys have had in Mr. Stafford's class. Solute is the thing that gets dissolved. Solvent is the thing that does the dissolving. Then we talked about our properties. And most of these you have had heard before. We'll get more into number 5 when we do some of the math in this chapter. And then we talked about liquid solutions. What is true about all liquid solutions? This is kind of a broad question, but
They're fluid.
that is a really broad question. What I'm trying to get at, when I say a liquid solution, I'm referring to
liquids.
no, I'm referring to the solvent as a liquid. Does that make sense? If I say solid solution, what am I referring to?
A solid.
Solid is the solvent. If I say a gas solution,
Not always.
Yeah, so they solve it. They both have to be the same.
for this vocabulary word, liquid has to be the case. But for liquid solutions,
It doesn't have to be solid.
yeah, you can have a solid dissolving in a liquid dissolving in a liquid, and even a gas dissolving. And I gave 3 examples of that. What was a solid dissolving in a liquid? Tea? Okay. What else? Tea's the only one?
Kool-Aid.
Kool-Aid, salt water, any solid that dissolves in a liquid. Then I gave you an example of a liquid. What was that?
Water and oil.
Rubbing alcohol. Watering oil would not be a solution.
Woo! That's not soluble.
Because it's
It
heterogeneous.
doesn't mix. Oh, no.
Yep. So I talked about any alcoholic beverage.
Diesel and
What's the deal with polyurethane things?
What do you mean?
Like, I'm watching Breaking Bad,
Okay, I have
Don't
never
spoil
watched
it.
that.
and I'm not spoiling anything, but he wanted to, they had his body, and they needed to get rid of it, and he was a chemistry teacher, and he's like, we're gonna get,
On dead body.
yeah, so he gets this really, it's
It's like a movie
hydro,
right now.
it's a hydro something acid, something like
Really?
hydrogen.
What do they like?
Yeah, I think so. And he tells this, he's working with a teenager, this still dude. He tells him to get a polyurethane plastic tub, I think.
Okay.
But he doesn't listen to him. He puts the acid in his bathtub and puts the body in it. And the bathtub, the bottom of the bathtub comes through his house and the body's just like, it's so gross. But I thought my question was
I'm guessing that poly whatever doesn't react with the acid.
well, why are they?
Well,
I don't know. I just wanted to say that story. That's something. That's what we Bell's dad.
her fingers.
Massive calves.
Hey guys,
Those are.
let's focus now.
It's not wrong. That's cow.
Do I need to close the blind?
No, I love the natural sunlight.
Well, then that's
Yeah,
cool.
you're
What light is there?
And then I gave you a gas dissolved in a liquid. Pop. Okay. Any big body of water that has nature living in it. Okay. Now, then I talked about these 2 vocab words, which the only thing that makes them difficult is they're uber specific. Why do I say that?
One separate gas. There's only 2 liquids.
Has to be 2 liquids. Has to be. So, does a solid dissolving in liquid even apply to this idea?
No.
We could say it dissolves, but we can't say it's miscible. Okay? So like oil and vinegar, those guys do not mix, so that would be immiscible, and it can be classified as immiscible because it's 2 liquids. Alcohol dissolved in water or vice versa, that would be miscible because 1, it dissolves, and 2, it's a liquid solution. I know. solid solutions. Actually, there's more solid solutions than you probably even imagine. Did you know solids can actually dissolve all three phases?
Yeah, you told us yesterday.
Sure.
Yeah.
I bet you can only think of maybe one. Maybe because it's on the board, but
Brass.
any alloy.
Any, I was about to say that.
What's an alloy?
Copper.
A metal mixture.
That's probably the most common one. A liquid being dissolved in a solid, an example of this is mercury can actually absorb into gold and it will permanently discolor it. So if you're trying to save up and get a bunch of gold and not, invest in the stock market because you think the stock market's going to crash, don't have any mercury anywhere nearby. That'd be bad. That's called an amalgam. Remember, write that down.
Was it stronger?
Okay, listen, write this down. A solution containing mercury is called an amalgam. A-M-A-L-G-A-M.
Oh, that's an amalgamation.
Where's my yeah? Oops. Amalgam.
Yeah.
Did you say a solution containing mercury?
Yep. Amalgam is a solution containing mercury. What?
Amalgam.
Amalgam?
It's containing? We're putting gravel in.
This is going to be a distraction.
They're putting gravel in the parking lot.
Okay, an amalgam. So, an example of solid is any kind of alloy. Example of
Wait, I didn't even write it.
a liquid dissolving in a solid would be like mercury dissolving in gold. Here's what's interesting. Here's an example of gas that can dissolve into a solid. Hydrogen gas, since it's so small, it actually can fuse its way into solid things, and that's one of the major hurdles for using hydrogen as a fuel source. Because there's a lot of hydrogen everywhere. You can make hydrogen fairly easily. But part of the problem with using it as a fuel source is it's such a small particle that it can infuse into the solid chamber that's holding it, and under high pressures, it weakens the solid to the point where it could actually rupture. Well, transporting that kind of goes by the wayside if you've got hydrogen gas that can sneak in. All right.
No!
I'm not even looking out there. I was thinking.
No, Kramer!
Don't stop looking. Oh, it's slow death. They died. What are they doing?
It's pouring gravel in the parking lot where the two are.
Okay. So here is kind of a big table. Gases can only dissolve other gases. Why do you think they cannot dissolve liquids or solids?
Because they can have more. Wait, no. I was gonna say more density.
So the only thing a gas can dissolve is another gas. Why can't they dissolve solids or liquids?
Because their particles are farther apart.
Yeah. Gases particles are too far apart that they can't contain or surround a particle that's really close together. Okay, so an example of a gas-gas solution is the air you breathe right now. Any mixture of gases is a gas-gas solution, assuming you can't see the distinct difference, which most of the time, most gases you can't see. Okay.
It's like smoke in air. What if we can't see oxygen? Except we're just used to
I
seeing
don't
it?
think smoke, I don't know what phase smoke is.
What is smoke?
What is,
What is
it's
smoke?
it's called a colloid, but it's not like,
Like Jello? Woo, Jello! Let's go eat
colloid,
some
Jello's not the only colloid. Mist, dust in the air.
Oh, what? We're already done. 20.
What?
20.
You're not done.
11:20.
I have a joke.
Okay, so here we have three things that need to happen for something to dissolve. Okay? First, in order to dissolve something, you've got to take the solute and separate it. For example, if I had a big cluster of sodium and chlorine making up table salts, the water needs to surround the individual ions, not a clump of ions. Does that make sense? Okay? So, in order to dissolve something, first the solute has to expand or be broken up into its smaller particles. Next, the solvent needs to be attracted to the solute. And we know that if it's not attracted, it won't dissolve. An example, oil and water. Okay? Then, after you have separated the solute, got it surrounded by the solvent, then it can diffuse through so that you can get more of the solute to dissolve. Okay? Every dissolving process involves this. Now, if I'm separating the solute, is that an endothermic or an exothermic process?
Solving?
Making this, expanding the solute or breaking the solute apart into smaller. What'd you say? It's definitely endo. Why?
Because it's getting energy.
Yeah, you're breaking bonds, aren't you, when you're separating the solute? Okay? How about the solvent-solute attraction? Is that endo or exo? How much trickier? Energy.
Exo, because it's forming.
Yep. Endo always breaks bonds. Exo is always the result of forming bonds. Okay? That's nothing new. We talked about that in multiple chapters.
I have the opposite. Breaking bonds, doesn't it release energy?
No, breaking bonds actually brings in energy, to break the bonds. That's why when it's in its broken form, it's highly energetic and unstable. That's why things want to bond. Because when they bond and form bonds, or when they come together to form bonds, they release energy to have lower energy and be stable.
Nonsense.
Why is
Their
that?
body uses ATP and A whatever, and when the breaking of the ATP releases energy.
Well, they get that energy from the sun, from causes or whatever this
No, but humans
is.
Like in our bodies,
Yeah.
convert. Yeah.
breaking bonds to create energy. In our bodies.
It's because it's forming something else.
No, just
I don't remember the whole process of
Yeah,
that.
it's like forming.
I don't remember the whole process of that. It's been a long time since I've gone through that, so I would be just stabbing in the dark at this point. So let's focus here because I do want to make sure we get through this lesson. What is this visual showing you?
the breaking and adding and subtracting.
It's the dissolving process. Here's your big chunk of, let's say this is table salt, sodium and chloride ions in a big chunk. Okay, water molecules come in. Do you think there's a reason why all of these water molecules are aligned the way that they're aligned? Polarity, right? These are your two hydrogens. That's the positive end of a water molecule attracted to the negative chlorine ion. And here's your oxygens. There's your negative end of your oxygen molecules attracting the positive sodium ion. So what happens is they come in and they grab, and due to the attraction, they pull it apart and surround it, and that's why you don't see it. Doesn't mean it's not there. It's like me taking a blanket and putting it over one of you. You can't see it because you've been surrounded by the blanket. Okay, but you,
Like in chapter 2,
Yeah.
they put it over as wing.
just because that's how big the particles are.
They put a blanket over her with a spinning pod. Enzyma, whatever. Enzyma? How do you say it?
If I put a bunch of big particles around her, like if I put a bunch of doors and surrounded her, you couldn't see her.
It exploded on the door.
You could see the doors. If you put a bunch of water molecules around, you can see the water, but you can't see what it's surrounding.
Look at the
You
part-
see water.
You can see water. You can't see the particle level, but you can.
Ew, that's-
So when I have a dissolved, when I have salt,
Why you can't see water?
Bye, bye, bye.
what do you mean you can't see water? What
You
kind
can't see it. It's not.
of what world do you
You
live
can see it
in?
when it's in a glass.
Sit. Aw,
She stole food.
Dude, the merit. Solvation.
Whoa. I prefer salvation.
I prefer salvation as well.
Solvation.
But solvation is the process in which your solvent particles surround and interact with your solute. Now again, another very specific vocab word because of has to be under certain conditions. So if I say alcohol is dissolved in water and the attraction of alcohol to water in that dissolving process, that's solvation, you would say no because it's liquid-liquid, it needs to be solid attracted to the liquid. Okay, so you're starting to see that these vocab words are very precise.
Yeah.
Solid, solute.
Okay, so it's not good enough just to say, oh, it's the dissolving of something. Well, it's really specific dissolving of something. Alrighty, then here's a couple other more specific vocabulary words. Hydration is just solvation in water,
Oh, thank God.
but still has to be solid dissolved in water. Does that make sense? Why does it have to be a solid dissolving in water?
Hydration is baptism.
No.
We're not dissolving in the water.
Okay, so like a bath bomb.
Unless you're Catholic, then salvation is in the water.
So hydration. We specifically said that solvation is a solid dissolving in a liquid. Okay, since water is a universal solvent, there's a pretty big category that we would call hydration. Anytime you have a solid particle dissolved in specifically water, it's going to be hydration. Now this sometimes can confuse, sometimes I wish they switch this around because this says ionization, but this is the one where you have an ionic compound that dissolves. And this is the one where you have a covalent compound dissolve. And the reason why they say that is because a lot of times they'll say ionic compounds dissociate, even though you probably may have heard me every once in a while say it ionizes. Okay, so this one you're going to have to, again, think a little bit about. Here we go again, all these vocab words that you have to engage in. You have to engage in.
No.
Okay? So, ionic. Now, this has to be in what form? Solid form. And this has to be in what form? Solid form. Okay? And it has to be dissolved in
All liquid.
a liquid.
Water.
I mean, water could make it work if water's in the liquid state.
Because they're all solid.
Alright, now, I brought this up a little bit ago. Engage, said it made no sense. Endothermic. What happens is energy has to be put in to break the bonds apart. When bonds are formed, it's more stable, so energy leaves the system. That's called exothermic. You remember endo and exo at least, right?
Yeah.
Is
Okay.
energy not stored in the bonds?
Yes.
Why doesn't it go into the bonds? Why does it come out? Exothermic.
So, are you talking about for an exothermic? Or for what?
Why wouldn't it be endothermic for it to form a bond because it has the energy in it?
It does have the energy, but it has less energy in it. When you form a bond, what you're doing, when bonds are formed, it has to do with what it was before and what it is after. Okay, if I have two atoms, are atoms by themselves stable? Very rarely. What are the only atoms that are stable by themselves? Double gases are the only atoms that are stable by themselves. Okay? So the reason why they form bonds is because they're more stable when they form those bonds. So what you have is initially unstable, high energy atoms that bond to form stable, low energy compounds. Well, if I go from high energy to low energy, I lost energy, didn't I? Where did it go? Well, it got released. So the formation of bonds is a releasing of energy, and the breaking of bonds is the absorbing of energy. Because, for example, if I have a stable, low energy compound, and I want to break those bonds, I put in energy, break them, and now I'm left with high energy atoms, because energy was put into low, stable compound, and broke up into highly unstable atoms. it's the same forward versus reverse on that. All right. So we won't do the math on this till next chapter. Okay. But when you have dissolving, the number one, not the only one, but the number one thing that tells whether it's going to dissolve or not is whether it's an exothermic or endothermic. Okay? And you aren't going to see this until next chapter. It's called enthalpy, but it's basically energy in the form of heat. Okay? So usually things will dissolve if they give off energy because things want to be in their more stable, low energy state. Okay? Things that don't dissolve, the reason why they don't dissolve is because it requires too much energy for them to dissolve. Okay? Now, it isn't the only thing because we haven't even talked about entropy. Okay? Things also want to be disordered, and usually when it's in the dissolved state, it's more disordered than it is if it were clumped together in a solid. That's more ordered than in the dissolved state. Would you agree with that? Okay. So that's a whole another set of stuff that we'll get to in a couple chapters. I think this is it. This is it.
Yeah.
Friction.
No, what's disassociation?
No, what is this?
What's what?
Disassociation.
We just went over that like 2 times.
Oh yeah, disassociation. I remember that. Nah, I just don't remember the words.
That's why you got to engage
We get out in 3 minutes.
in the word.
We get out? Oh.
Any questions on this stuff? Something that when I went through, you weren't particularly understanding. You want me to
George,
maybe?
my homework now.
Well,
Yep.
I was looking at the homework yesterday, and one of the questions was about